in lecture number 3 of Engineering Mathematics 2 MTL 1026. In this lecture, we will discuss about the non-homogeneous differential equation and all those non-homogeneous differential equation which is convertible into homogeneous differential equation of first order and first degree. Okay. Later on, we will discuss about Pfaffian differential equation. What is Pfaffian differential and Pfaffian differential equation? And then after Pfaffian differential equation, which is the general form of exact differential equation, we will discuss about the what is exact differential equation and how to find the solution of exact differential equation. Okay, so let us see what is non-homogeneous differential equation of first order and first degree. Of the form dy by dx equal to ax plus by plus c divided by a prime x b prime y plus c prime, right? Where the condition is that a by a prime does not equal to b by b prime. Such type of differential equation is non-homogeneous differential equation. This is non-homogeneous form. Okay. Then convert it into homogeneous form. How we convert it into homogeneous form? It is not homogeneous in y and x, but it is converted into capital Y and capital X. Homogeneous form of capital Y and capital X. It is converted into homogeneous form in capital Y and capital X. How we convert it? So let us apply the transformation. Let small x is equal to capital X plus H. Small y is equal to capital Y plus K. Then d small x is equal to d capital X and d small y is equal to d capital Y, where h and k are constant. This h and k are constant. Okay. Then dy by dx can be written as d capital Y by d capital X. Okay. So this differential equation 1 converted into this form. D small y by dx is written as d capital Y by dx is equal to a into small x, a into x plus h, that is ax plus ah, by b into capital Y plus bk, b into capital Y bk, plus c. Okay. Similarly, the denominator a prime x, b prime y, a prime x, b prime k, plus c prime. Right. Now choose such h and k. In this case, choose such h and k such that these two linear equations become 0. Ah plus bk plus c is equal to 0. A prime h b prime k plus c prime equal to 0. So this differential equation becomes d capital Y by dx is equal to ax plus by divided by a prime x plus b prime y. Okay. Now this equation is homogeneous. This is homogeneous differential equation in y and x, capital Y and capital X. Why it is homogeneous? Since it can be written as d capital Y by dx is equal to function of y by x. Okay. So this differential equation become homogeneous. Now once the differential equation become homogeneous, we can apply the same procedure to find the solution of differential equation as we adopt in homogeneous differential equation. Okay. So let us see some problem. See, dy by dx is equal to x plus 2y minus 3 to x plus y minus 3. Now, this differential equation is non-homogeneous. Non-homogeneous differential equation. Remember, we are talking about non-homogeneous differential equation of first order and first degree. Okay. So let us apply the transformation. Let small x is equal to capital X plus c and y is equal to capital Y plus k. So dy by dx is equal to d capital Y by d capital X. Okay. Then dy by dx is equal to, put small x is equal to capital X plus a. So capital X plus h, and y is 2 capital Y plus 2k, and h plus 2k minus equal to 0. Similarly, denominator 2 capital X plus capital Y and 2h plus k minus 3 equal to 0. Right? And solve this, find h and k. Solve this, find h and k. Right? Now, this differential equation, after using this transformation, small x is equal to capital X plus h and y is equal to small y is equal to capital Y plus k. Equation 1 converted into equation 2 is equation 2. Okay. This equation 2 is homogeneous. This equation is homogeneous. Homogeneous in capital Y and capital X. Okay. So apply the method of homogeneous differential equation. Let capital Y capital X is equal to V. This implies that capital Y is equal to capital XV. Okay. So d capital Y by d capital X is equal to V plus X dV by dx. Okay. So this dy by dx can be written as V plus X dV by dx. And this thing can be written as 1 plus 2V, 2 plus V. Okay. So 1 plus 2V divided by 2 plus V minus V. 1 plus 2V, 2 plus V minus V is equal to capital X dV by dx. So after solving this, 1 plus 2V minus 2V minus V square divided by 2 plus V. This one is cancelled out. So this becomes the variable separable. Variable separable in small b and capital X. So dx by x is equal to this thing. And convert it into partial fraction. Converted into partial fraction. Okay. And integrate. After integrating, we find this solution. Right. Write small b is equal to capital Y by x and simplify to find this solution. Okay. Now come to the Pfaffian differential. What is Pfaffian differential? A differential of this form is known as Pfaffian differential. F1, Ex1, Ex2 up to Xn, dx1, F2, X1, X2 up to Xn dx2 plus that is 1 Fn, X1, X2 up to Xn dxn is equal to 0. Okay. So this is known as Pfaffian differential. This is known as Pfaffian, not equal to 0. This is known as Pfaffian differential. Okay. If this Pfaffian differential, this is equal to 0, then this is known as Pfaffian differential equation. Okay. So Pfaffian differential equation in n variable. In n variable. Now apply one restriction. Consider Pfaffian differential equation for two variables. Yes, this type of differential equation. Pfaffian differential equation in two variables. Pfaffian differential equation in two variables. Okay. Pfaffian differential equation in two variables. That is in this form. F1 X1 X2 dx1 plus F2 X1 X2 dx2 equal to 0. Right? This is the Pfaffian differential equation in two variables. Or this thing can be written as m into xy dx plus n xy dy equal to 0. Okay. This thing. What is this? This is Pfaffian differential equation in two variables. Okay. Now This Pfaffian differential equation in two variables is said to be exact. When when it is said to be exact, this differential becomes exact if the partial derivative of capital M with respect to y is equal to partial derivative of capital N with respect to x. Okay. Partial derivative of y with respect to partial derivative of capital M with respect to y equal to partial derivative of n with respect to x. So this equation becomes exact when this condition is true, and conversely, when this condition is true, then this equation becomes exact. Means this is the necessary and sufficient condition that to a Pfaffian differential equation two variable is exact. What is necessary and sufficient? Necessary and sufficient condition is that a differential equation m dx plus n dy, remember that capital M and N are function of xy, function of x and y. So m dx plus n dy equal to 0. So this differential equation is exact if and only if dou m by dou y is equal to dou x. Okay? If this is true. Okay? And second definition, this differential equation becomes exact if this condition is true. One more definition. Suppose differential equation m dx plus n dy equal to 0. For this differential equation, 1, for 1, there exists a function fxy such that the total derivative of the function d of fxy becomes the differential equation m dx plus n dy. Okay, if there exists any such function, then this differential equation becomes exact. Then 1 becomes 1 becomes exact. Okay, then this 1 becomes exact. Okay, see some example. Let us consider this. Okay, m dx, m is y square, and this one is capital M. So dou m by dou, what is dou m by dou y? Equal to 2y. And what is dou n by dou x? Dou n by dou x is 2y. So these two are equal. Hence equation is exact by this method. By this method, this is exact. And by second method, is there exist any function fxy? Yes. What is that function? Fy square. If we consider fxy equal to fy square, then its total derivative of fy square equal to, so first function x, second y square. So x, and derivative of y square is 2y dy plus y square second function. What is derivative of x? So this differential equation is nothing but, so there is a function square whose total derivative is differential equation. Hence this differential equation is exact by this method also. But what is the problem in second method? It is not always easily found the function fxy whose total derivative is differential. Okay, for a differential equation is given, it is not easy to find out fxy whose total derivative become this differential equation. So to solving such differential equation, we will apply this method 1. Okay. Once we verify whether the differential equation is exact or not, after that we find the solution. So what is the method of finding the solution of a differential equation? This is the necessary and sufficient condition for the differential equation. This becomes exact. This differential equation is exact if this condition is true, and if condition is true, then differential equation is okay. So we are talking about once the differential equation is exact, once we will verify what the given differential equation is exact, then how we evaluate the solution of the differential equation. Okay, so the given differential equation is x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy equal to 0. First check whether the differential equation is exact or not. So compare this differential equation. Okay, this whole differential equation with m dx plus n dy equal to 0. So what is capital M? Capital M is x minus 4xy minus 2y square. And what is capital N? Capital N is y square minus 4xy minus 2x. What is dou m by dou y? Dou m by dou y, derivative of x square is 0. 4xy minus 4x minus 2y square means minus 4y. Okay. And what is dou n by dou x? Dou n by dou x, y square 0 minus 4y minus 4x. Okay. Now see, dou n by dou x and dou m by dou y, these two are equal. These two are equal. Hence, given equation 1 is exact. Once the equation is exact, how to find the solution? Solution is found by this formula. Integrating the formula. First, a differential equation. What is the procedure of solving this type of differential equation? M dx plus n dy equal to 0 by exact method. This differential equation is given. Second, verify the differential equation. This differential equation is exact or not by dou m by dou y is equal to dou n by x. So our answer is yes or no. If no, then we will see later. If yes, then the solution is find out by this method, integrating capital M with respect to x and treating y as constant, plus integrating those terms of capital N, does not containing x, and dy equal to constant of integration. Means integrate capital M treating y as constant and integrate not all terms of n but only those terms of n which does not containing x. Okay, so this is the formula. When the differential equation of first order and first degree become exact, then we will find the solution of the differential equation using this formula. Okay, so m dx, what is m? X square minus 4x minus 2 square dy. Okay, plus C capital N. In capital N, which term does not contain? What is capital N? Then x square minus 4xy minus 2. Okay, sorry, plus y square. Check what is capital N, which does not contain. Okay, so this term containing x, this term does not contain x. Okay, then x square with x cube by 3, minus 4xy minus 4y, and integral of x, y is constant. Okay, y is minus 4, 4 is constant, y is constant, and here x plus y minus 2y square means 2x equal to, sorry, plus y square, y cube equal to constant. Now simplify this, you got this solution. Okay. 1 plus e to the power x by y dx, e to the power x by y, 1 minus x by y dy equal to. Now see, this differential equation of the form m dx plus n dy equal to 0. What is capital M? Capital M is 1. Coefficient of dx is capital M and coefficient of dy is capital M. What is capital M? E power x by y, 1 plus x by y. Right? What is capital M? 1 plus e power x by y. So differentiate capital M with respect to y. X by dou y. Dou m by dou y, derivative of y is 0. E to the power x by y, x by y. Derivative of x by y with respect to y. Minus x by y square. What is dou by dou x? Differentiate term. Okay. After differentiating this term, we got this. Okay. And simplify this term. See, this term is cancelled out. This one and this one is cancelled out. Now this becomes minus x by y square e to the power x by y. So this is dou n by dou x, and this one is dou n by dou y. So these two are equal, and the equation is exact. Once the equation is exact, how you will make the solution? Integral 1 plus e to the power x by y dx plus Those term of capital N does not contain x. See, this term e to the power x by y is multiplied by 4, and this term containing x. So all the terms containing x. So capital N, no term here, this does not contain x. So each and every term containing x. So this is okay. Means no term we consider here. This is equal to constant of integration. So integral of 1 is x. Integral of e to the power x by y, e to the power x by y, and x by y. Okay, e to the power x by y. No, this is e to 1 plus e to the power x by y dx. Okay, integrate this. So dx e to the power x by y dy, sorry, dx, this one is x, right, plus e to the power x by y and divided by 1 by y equal to constant of x. Okay, so this becomes this. This is the solution of this exact differential equation. Now see some problem. Suppose a differential equation m dx plus n dy equal to 0. Suppose for this differential equation dou m by dou y, dou n by dou x does not equal. Okay, this differential equation, for this differential equation dou m by dou y does not equal to dou n by dou x. Okay, it means this m dx plus n dy is not exact, because since dou m by dou y equal to dou n by dou x, this is the necessary and sufficient condition. So m dx plus n dy equal to 0. If dou m by dou y does not equal to dou n by dou x, then this differential equation is not exact. So if this differential equation is not exact, whether it can be converted into exact form? Yes, it can be converted into exact form. How? If we find out some function f, and after multiplying if we consider m dx plus n dy equal to 0, this differential equation is not exact, but it converted into exact. Converted into exact form. How? How? Find a function f. Find a function fxy such that m into f dx n into f dy equal to 0. Now this differential equation become exact. Okay, this differential equation is not exact, but after multiplying by this function f, this differential equation become exact. Now such fxy is known as integrating, and we call it integrating factor. Now our next problem is how to find the integrating factor. There are any general method, whether there exists any general method to find such integrating factor of first order and first degree differential equation of the form m dx plus n dy equal to 0. Okay, so there does not exist any general method, but some rule exists to find out the fxy. Okay, so we will discuss these rules one by one.